Good evening, everyone. Welcome to week 8 of the live interactive sessions for integrated waste management for a smart city offered through NPTEL. My name is Sethi Vinayagam. I am a PhD scholar in the Department of Civil Engineering at IIT Madras. Okay, we'll start this week's session by looking at the concepts that were covered in the lectures of week 8. So the first lecture for week 8, we continued the discussion on the thermal treatment. Okay, so in the first lecture, we continued the discussion on thermal treatment, which was started towards the end of last week. So we looked at the stoichiometric combustion. So what in that we looked at how, given by knowing the amount of the different elements that are present in our organic solid waste, like the percentage of carbon, nitrogen, sulfur, hydrogen, and so on, how can we know the exact air requirement or the oxygen requirement to do the combustion process, right? So we started with that. Then we looked at the mechanisms or the different phases that are present in a combustion process. So how what are the different mechanisms or the different processes that take place when we combust the organic solid waste or the solid waste. And then we looked at also the different types of incineration, right? So we looked at fixed hearth incinerators and also the rotary kiln incinerators. And then in the second lecture, we looked at what is the role of thermal treatment, right? How it helps us to minimize the volume of waste that goes to the landfill, right? And effectively increases the life of the landfill, right? So those are the we looked at other uses of the thermal treatment or the other advantages that it provides. And then we went into conventional thermal technologies. What are the different conventionally how we do the thermal treatment of the solid waste. And then in lecture 38 we looked at what are the requirements for an ideal incinerator. And then we also talked about what are the different air pollution control issues that arise. And in 39, the fourth lecture, we looked at the advanced thermal technologies such as pyrolysis, gasification, and plasma technologies, and then worked out some example problems. And in the final lecture, so after the thermal treatment, we went into the basics of landfills, and then we looked at we ended it with the requirements for the liner, so which is to prevent the seeping of the leachate into the groundwater, right? So what are the requirements for a liner system for an engineered landfill? So that's what was covered in week number 8. So we'll continue and look at some of the questions related to these concepts in this week's session. So the first question is, select the correct order of steps in the combustion process. So as I said, we looked at the mechanism of the combustion process in the first lecture of week 8. So here we need to arrange those processes or the mechanisms in the correct order. Right? So we have different phases. So the options, so the order is jumbled in these different options. So for example, in the option A, we have the drying phase followed by volatilization of vapors and gases, followed by burn down of char, and then burn down of solids. So this is jumbled, so we need to pick the right one. So the right option is option D. So where we start with the drying phase, right? So when we uh, so I'll keep the explanation later, because in the next question we'll look at what do these different phases mean. So the first, we start with the drying phase where the moisture is driven off, then volatilization happens of the different vapors and gases, then the burn down of solids take place, and finally the burn down of char. So that is the correct order in which of the mechanisms that take place in the combustion process. Okay, so question two. This is again related to the same question on the mechanism. So here we need to match. So the four phases are given in column A, and we need to match with the correct description of what happens in these different phases. So we have the drying phase, volatilization of vapors and gases, burn down of solids, and the burn down of char. And there are different descriptions are given. So in some phase, fixed carbon volatile matter are oxidized, moisture is driven off in some phase, the remaining char is burned down to bottom ash, and combustion of volatile organics takes place. So we need to match these phases along with the to the correct description, right? So the different combinations are given here, and we have to pick the right option. So maybe we can do a poll, and then so where you can take a couple of minutes to think about it, and then provide your answers, and then we look at the correct option. Okay, I'll create a poll. In the meanwhile, you can recollect um, the descriptions and then answer it. So the poll is launched. Once you are ready with your answers, please answer the poll. Okay, I have one answer in the poll. What about the others? So we have a couple of answers saying it is option B. We'll see the answer now. So B is the right option. So where option 1 is matched in column A is matched with option 2 in column B. So the drying phase, in the drying phase, which is the first phase of the combustion process. So where the moisture that is present is will be leaving the solid waste, right? So we heat it up to 150 degrees, and at this point, all the moisture that is present in the waste will be dried. So that is the first phase, that is the drying phase. The next is the volatilization of the vapors and gases. So once the moisture leaves and we further heat this waste to higher temperatures, so whatever are the volatile organics that are present and are combustible, so those will be leaving the waste once their flash point occurs. So flash point is that lowest temperature at which the volatiles will leave from the waste, right? So that is the flash point. So once we reach those flash points, so different components will have different flash points. So we continue heating it. So for that, so at once the flash points for the different elements are reached, so all of those volatile elements will be leaving the waste. That is the second phase. And the third phase, once these vapors and gases are left, the solids are remaining. So these solids will start burning now. So the fixed carbon, or whichever is which was not which did not vaporize, so those material will then start oxidizing, right? So this is at a temperature of 700 to 1100 degrees Celsius. So that is the third phase. And then the final phase is the burn down of char, right? So whatever is remaining after this oxidization of this fixed carbon, whatever is remaining, those material will be further burnt down, and finally we will have the final residue, which is the end product, which is called as the bottom ash, right? So that is the final end product of the combustion process. So these are the correct descriptions of the four phases that takes place during the combustion process. Okay. So here is the slide which discusses about this from the lectures, right? So we have this first phase, drying phase, where moisture is driven off. The second phase is the volatilization, where the combustible volatile organics will be diffusing. Then the solids will be burned down by the fixed carbons, and finally the char is burned down, and we get the bottom ash, which is the end product. Okay, so question number 3. Baghouse or the fabric filter is used to remove which of the following pollutant generated during the combustion process? So the options are NOx, sulfur dioxide, particulate matter, acid gas. Again, I'll create a poll for this. So what do we use this equipment called as a baghouse in the combustion process? So we have different pollutants that are generated when we do the combustion. So to control which of these pollutants is this baghouse or fabric filter used? Okay. A couple of people say it is option C, particulate matter. Do we have any other answers? Okay, so we'll look at the answer. It is option C, particulate matter is the correct one. So again, so all these are different pollutants that we are producing. So there are different techniques we use for controlling these. For nitrous oxides, we use generally ammonia, right? So that is used to control NOx. For sulfur dioxide and also acid gases, something called as a dry scrubber is used, right? whereas this baghouse or the fabric filter is particularly used to control the particulate matter, right? So all the fine particles which get mixed with the air. So to remove those out of the air, we use the baghouse filter, so which is a fabric filter, right? So we have long bags which are made of specially designed fabrics that will trap these particulate matter. So we use that generally to control this particulate matter. Question 4. Which of the following waste to energy system uses the highest temperature? So the options are fluidized bed, pyrolysis, plasma arc, and gasification. Okay, we have a few answers. So which is option C. Okay, any other answers before we look at which is the correct one? Okay, so let's look at the answer. It is option C, plasma arc, right? So this is this is an advanced technique of waste to energy system, right? So when we talk about waste to energy, there are different techniques that are out there. There are some conventional techniques, so which includes this fluidized bed method, and there are some advanced techniques such as this pyrolysis, plasma arc, and gasification. But out of all of these, plasma arc is the highly energy intensive process, right? So here we heat our waste to very high temperatures, so in the order of 2000 to 6000 or even up to 10,000 or so. So when we do it, when we heat it to that extreme temperature, what happens is that almost all of these matter that is present here will be destroyed, right? So it will be converted into these ionized states. So for doing that, we need a very high amount of energy, because we need to raise the temperature to these high levels. So for that, we need to supply a lot of energy. That's why this plasma technique is a very highly energy intensive technique. And there are advantages to this, because it's going to destroy almost all of the material that we have. So it is going to help us, but on the other hand, the trade-off is that it requires a lot of energy. So that's the plasma technique. So question 5, again it's a related one. So using which of the following thermal treatment technology, hazardous and medical waste can be effectively treated with the lowest amount of residuals? So the options are mass burn, plasma arc, pyrolysis, and gasification. So here we are talking about the amount of residue that we end up with. Right? So in which technique do we get the least amount of residue? Yeah. So we have a couple of answers for option B. That is the correct answer. So plasma arc leaves the lowest residue, and also we see that it is an effective technique when we are dealing with hazardous waste and medical waste. Why? Because we are heating it to a very high temperature, right? So all the organics are totally destroyed. So any contaminants that are present is effectively treated when we are doing this high temperature plasma arc technique. And also the volume of residue that we are going to be ending up with is going to be the lowest among all the other processes that we have for thermal treatment. So that is the advantage of having this plasma. But because it is very energy intensive, we don't go for use it for the municipal solid waste because it's not going to be economically feasible generally. But when we are talking about this hazardous waste and medical waste, it is, since it is very effective, we use it mostly for dealing with those kinds of waste. Question number 6 is, which of the following statement is true for air pollution control measures taken during the thermal treatment of waste? So the options are: cyclone separators are used for efficient removal of particulates using an electrostatic charge. B. Baghouses are used for efficient removal of particulates using an electrostatic charge. C. Baghouses are used to remove particulate matter using fabric filters. And option D is none of these. So here again we are talking about air pollution control. So which of these statement correctly describes the different processes? Yeah. So we have answers as option C, and that is correct. So the first two options talk about use of an electrostatic charge, right? So when we so electrostatic charge is used in a technique called as electrostatic precipitators, right? So we use electrostatic charge in the electrostatic precipitators, so to remove particulate matter, small particulate matters. Whereas baghouse, as we saw in one of the previous questions, so it is a fabric filter. So we use specifically engineered fabric materials, right? So to remove the particulate matter. So that is the correct description out of all the three that are given here, right? So that is the correct one. So in baghouse, we use the fabric filter. But the other two are talking about electrostatic charge, which is not used in either a baghouse or a cyclone separator. Whereas cyclone separators are for removing relatively larger size particles. Electrostatic precipitators are for smaller particles. So here again, we discussed about these different methods in the lecture. So the electrostatic precipitator, again, that uses the induced electrostatic charge. So when the gas flow through this electrostatic precipitator, because of this charge, we will be attracting the particulate matters. And then in the baghouse, again, as I said, we use the engineered fabrics of long bags or tubes that will filter out these particulate matters. And for our acid gases, we use the different scrubbers as wet, dry, or some chemicals. And we have other techniques such as activated carbons or catalytic reductions and so on. Question 7 is, highest percentage of particulate removal can be obtained using which of the following air pollution control system? Option A is Venturi scrubber, option B spray dry absorber, option C is packed bed wet scrubber, and option D is dry electrostatic precipitator. mix of answers, A, C, and D. Okay, so we'll look at the answer now. It is actually option D, the dry electrostatic precipitator. That provides the best particulate removal, right? So we looked at these four techniques or methods, right? So spray dry absorber, venturi, packed bed, and the dry electrostatic precipitator, and we compared these based on different parameters, like such as particulate removal, heavy gas, heavy metal removal, acid gas, residue, and so on. So with respect to particulate removal, if we compare these different methods, so this dry electrostatic precipitator provides an excellent removal, whereas the others are not that good relative to this, right? So because each of these are targeted at filtering different things, whereas we look at heavy metal removal, so it is spray dry absorber performs better, right? So like that. So whereas if you look at acid gas removal, in that case the packed bed does better, right? So the wet scrubber. So these, each of these are good at doing different things. So when we are looking at the particulate removal, it is the dry electrostatic precipitator. So as we looked at in the previous question also, in this electrostatic precipitator, we get is used for particulate matter removals, right? Whereas the scrubbers are generally used for the acid gas removals and so on, right? So it is, the correct option is option D. Question 8 is, match the following properties of the ash produced with their description during the thermal treatment of the waste, right? So we have different properties or the desire that are desirable for us. So those are non putrescible, sterile, and inert. So these are the different properties. So some descriptions are given. So we need to match what this property means, right, to the description. So what do we mean by non-putrescible? What do we mean by sterile and inert? Okay, we have again a mix of answers here, B, C, and D. Okay, any other answers? Anyone thinks it's A? Okay, so let's take a look at which is the correct answer. So it is actually option D. Right, so we have non-putrescible. So that what it means is that it does not decay. So non-putrescible means it is free of organic matter, right? So when there is no organic matter, there is no decay that is going to happen, and there will not be any odor that will be formed, right? So that's what we mean by non-putrescible. It is not going to have organic content, and therefore it means that it's not going to decay. And so second one is sterile. Sterile means it is free of any living organisms, right? So when we We would have heard of this sterile containers, right? So in labs and all, they talk about it, which means it is free of any microorganisms, so, or in general any living organisms. So that is what it is. It means to be sterile. And then third one is inert. Inert means it doesn't react, right? It stays as it is. It is not going to react with anything, right? So that's what we mean by inert. So these are the properties that we ideally need in the ash, because we are going to dispose the ash that is going to be produced from this at the end of the thermal treatment. We need to dispose it should not affect our environment, so we need it to be non-putrescible, so that it doesn't decay, it doesn't create any odor problems, and it doesn't produce any leachate and so on. And it needs to be sterile so that it doesn't contaminate anything, and also it should not react, so therefore it needs to be inert as well, right? So those are the descriptions of these properties. Okay. So we looked at this when we talked about the ideal incinerators in the lecture, right? So we talked about this, the continuous gas generation, and then these are the ideal properties: the non-putrescible, sterile, and the inert. Okay. So question 9 is, which of the following factors control the head on the liner system in the landfills? So option A is the liner slope. Option B is impingement rate. Option C, hydraulic conductivity of leachate collection system. And option D is the number of the horizontal and vertical wells. Okay, for this you can use the chat, because we are discussing multiple select questions, so where more than one option could be correct. Okay, I have options as A and C. Anything else that can affect the head on the liner system? Okay, A, B, and C. Okay, B. Okay, any other answers? Okay, A, C, and D. Okay, all right. So we'll take a look at the answer now. So most of you have rightly said it is A, B, and C. So all these three factors affect the head on the liner system, but D doesn't affect, right? So how we'll look at how they affect. So liner slope. So when we have a higher slope on the liner, so it means that large or at a higher rate we can get the leachate out of the landfill, right? Because the slope is higher, so the flow out of this landfill will be higher. Whatever is collected can quickly drain out, right? So that's how higher the liner slope affects. So if you have a higher slope, the gravity will help you to get the to drain it more quickly, right? So slope will affect the head on the liner system. Impingement rate is just the opposites, right? So we looked at the outflow, right, from the landfill. The impingement rate is about the inflow, how much water gets collected into this leachate control system, right? So it is like the input. So how much is coming into the leachate collection system? If the rate is high, if more leachate is coming onto this leachate collection system, so higher will be the head on the liner, right? So more is the input, so more will be the head. So it is the how much is coming into this landfill. whereas the liner slope is about how much is going out of this landfill. So both input and output is going to affect the head on this liner system. And C is, you can say, about it is in between, right? So once we have some input, we have some output, in between something happens. So that is this hydraulic conductivity of the leachate collection system. So how this collected or the incoming leachate or the water or the wastewater, how quickly it can enter into this collection systems and then leave out of this landfill through this slope that we have provided. So right, so that is controlled by this hydraulic conductivity. So whatever material is used to surround this pipes that we are putting it over this liner, right? So what is the conductivity of this or the permeability of these material is also going to determine how much or how quickly this water will drain, and therefore that will affect the head on the liner system, right? So we have the impingement rate, how much is coming in. So the more quickly this leachate or the water that is collected, so higher will be the head. If it is going to come at a slower rate, the head also will be lower. Second, once we have this, how quickly it can enter into this leachate collection system and the pipes, and then into those pipes, right? So into those, so that is determined by the hydraulic conductivity or the permeability. So if it is more permeable, quickly it can enter into those pipes and then leave out. And the third one is the slope. Once we have this water entering into those pipes, so higher is the slope, higher will be the rate at which it can leave the landfill system, right? So that's how these three factors control the head on the liner system, right? So whereas this vertical and the horizontal wells, they do not generally affect, because it is going to be outside of this, and where its capacity is going to determine how long we can store and so on, but it's not going to directly affect the head that we have on the liner system. Question number 10 is, out of the following principal elements of the municipal solid waste, oxygen is required for combustion of which of the following elements? So this is all under the ideal combustion conditions. So the options are carbon, nitrogen, hydrogen, and sulfur. So for which of these elements, to combust which of these elements do we need oxygen under this ideal combustion conditions? So which of these basically gets oxidized? Okay, you have one answer, A and C. What about nitrogen and sulfur? Okay, option A. Okay, everyone says agrees that carbon needs, but what about other elements? A, B, and D. Okay, okay, A, C, and D. Right, so almost every element has been covered in these different combinations. Okay, any other options before we look at the answer? Okay, so let's take a look at the answer. So everybody agrees, or doesn't seem to confuse that carbon requires oxygen, right? So we know carbon is going to produce carbon dioxide. So so all of these organics that are going to be there, so they are hydrocarbons, right? So hydrogen and carbon is definitely going to be there, and these two elements will also get converted into carbon dioxide and water, right? So carbon becomes carbon dioxide and hydrogen will become water by combining with oxygen. So when we do the combustion, so also sulfur will also get converted into sulfur dioxide. So it is these three, carbon, hydrogen, and sulfur, which are going to take up oxygen and then get oxidized into carbon dioxide, water, and then sulfur dioxide. Whereas nitrogen will remain as molecular nitrogen itself, N2. Because this question is about under ideal combustion conditions. So under ideal combustion conditions, we do not, the temperatures are not as high as it is required to convert the molecular nitrogen into nitrogen dioxides or nitrogen oxides. So that takes place only at very high temperatures, more than 1200, 1300 degrees Celsius. So those are the temperatures that are required to convert for nitrogen and oxygen to react and produce and to oxidize nitrogen, right? So those temperatures are not what we usually work with when we talk about ideal combustion conditions, right? So in at those conditions, it is only the carbon, hydrogen, and sulfur which will get oxidized, and therefore these three needs the oxygen and not the nitrogen. Okay, any questions? Okay, so moving on to question number 11. Which of the following statements are true for different incinerator types? So option A is fixed hearth incinerators are normally used for smaller quantities of waste. Option B is rotary kiln incinerators are used for smaller quantities of waste. C is the secondary chamber of the rotary kiln is used for gas phase combustion. And D is the secondary chamber of the fixed hearth incinerator is used for the gas phase combustion. So we looked at these two different types of incinerators in the very first lecture of this week, the fixed hearth and the rotary kiln. So which of these statements are true about these two types of incinerators? Okay, we have one answer C. B and C. Any other answers? Okay, so we look at the correct answer now. It is options A and C, right? So when we are dealing with smaller quantities, we just go for a fixed hearth incinerator, right? So it is more suitable for smaller quantities as opposed to a rotary kiln. So B is not correct, only A is correct. And with respect to the gas phase combustion in a secondary chamber, it only happens in the rotary kiln. We don't have a separate gas phase combustion in a fixed hearth incinerator. It is just a single phase where the waste is put into the hearth and then it is burned and the ash comes out, right? So that is the fixed hearth. Whereas in a rotary kiln, we have this gas. So from the initial combustion, so the gases which are released will be going into the secondary chamber where the further combustion of those gases take place. So that happens only in the rotary kiln incinerator. Therefore, the correct statements are A and C, right? So this is from the slides where it was discussed. So in the fixed hearth, it is generally used for the smaller quantities. So when we are working with medical waste, pharmaceuticals, or in a research and development facility, so where we are not going to have a very huge quantity of waste, so we go for the fixed hearth. right? So the waste gets into the incinerator, gets combusted, and then the ash comes out, right? So that's all that happens in the fixed R. Whereas in the rotary kiln only, we have two separate chambers, and in the primary chamber, the waste is charged, and then it slowly rotates, right? So the slow rotation will create turbulence, and also air gets mixed, and then once the material starts burning and whatever is the gas or volatiles that are released, so those will enter into this secondary chamber where the second phase or the gas phase combustion takes place. So those are the two types of incinerators. Okay, so moving on to question number 12. Which of the following processes come under the category of conventional waste to energy technology? So the options are plasma, fluidized bed, pyrolysis, and rotary kiln. Which is a conventional way of doing waste to energy. Okay, we have option B, fluidized bed. Okay, okay. Option C, option B, C again, B. Okay, so people switch between B and C. Okay, any other answers? Anybody thinks it's A or D? Okay, so let's take a look at the correct answer. It is actually both B as well as D. So we looked at in one of the previous questions, so where plasma pyrolysis and gasification. So these are advanced techniques, right? Whereas when we talk about conventional techniques, it is the fluidized bed as well as this rotary kiln that we just discussed previously. So these are what we have been using conventionally. So other conventional techniques, though, those include mass burn or just incineration, or right, or combustion, and then fluidized best, modular, and the rotary kiln, as well as this refuse derived fuel. So what is the refuse derived fuel? So we take this solid waste. So it is a heterogeneous mix of different waste materials, right? So we convert this into homogenized fuel, right? So smaller homogenized fuel, which is called this refuse derived fuel, which can then be used for deriving energy in a separate process, right? So that is also a conventional process. So whereas this plasma pyrolysis, which is combustion in the absence of oxygen, and then the gasification. So these are advanced techniques that we use for waste to energy generation. Okay, so question number 13 is, which of the following statements are true for solid residues generated during the thermal treatment of waste? Option A is bottom ash is suitable for road base and landfill cover. Option B is fly ash is suitable for road base and landfill cover. Option C is fly ash usually needs to be stabilized before disposal, and D is bottom ash needs to be stabilized before disposal. So which one do we use for the road base, or using in road base or in covering the landfill, and which one needs stabilization before we dispose it? Okay, we have options A, B, A, A, C, A, D, A, C. Okay, everyone agrees with A, but the other ones are varying between C and D. Okay, any other answers before we look at the correct one? Again, A, D. Okay, so let's look at the correct one. It is actually A and C, right? So when we bottom ash is more suitable when we want to use it for when we are laying the road as a road base, or to use it as a landfill cover. And then with respect to stabilization, fly ash needs stabilization or treatment so that it is not toxic before we dispose it into the landfill, right? So those are the correct statements. So this was covered when we looked at the waste to energy technique, right? So the bottom ash is what is more suitable for road base or as a landfill cover, or it can directly be disposed as well. Whereas if we want to look at fly ash, it has to be before when we dispose it, it has to be stabilized, right? So those are the two correct statements about these two. Okay, so that brings us to the end of week 8. So this was the last question. So if you have any questions, you can ask any questions or doubts that you have, or if you do not have any questions, you can feel free to leave the call. Thank you, and we can meet again next week at the same time. I'll just wait for a couple of minutes in case you have any questions. If you do not have any, you can leave. Thank you.